how does that potential timeline, right? How does that affect, next series of funding, right? Like, is it just, signs of progress, which will potentially lead to getting that next step in funding, that next series in funding before that 2 to 3 years is up? Or is it like kind of, once we're there 2 to 3 years from now, then we can evaluate, next funding options?
I would personally be inclined to take actions before the world all agrees, right? Meaning please don't wait until when everything is clear and then take actions. I would think the whole point of startup is being able to take risk and take actions quicker with more agility, with stronger focus compared to bigger companies. Part of that involves actually understanding what's going to happen, but a big part of it is probably
Hello, everyone. Welcome back to the It's Material World podcast. I'm Puneeth. I'm with David, and today we discussed the CHIPS and Science Act, CHIPS standing for Creating Helpful Incentives to Produce Semiconductors. And really, the goal is to just carry out activities relating to creating incentives to produce semiconductors domestically in the United States. And so our guest today, Ming, has a lot of expertise or experience in this space, and he was able to share kind of the current state of MSE. We're kind of changing things up a little bit for this episode and discussing current MSE events. And it was a really thorough and insightful discussion. But David, I wanted to hear your input, your thoughts. What was most exciting about our discussion today?
Yeah, I think that first off, I think that Ming did a great job explaining the legislation. So as someone who knows briefly about chips, I think it was very interesting to hear the rationale about how we're giving money, where we're giving money, and the plan for the money. And so he talked much more about sustaining it. And so I thought it was interesting just from a different perspective because legislations I don't think we've ever talked about before. So I thought that was number one. And number two is, I think a recent episode that we'll release the week before this, we just talked about very R&D scale manufacturing of semiconductors and a new type of way to do it. And so now we shift the perspective to how do we get other crazy ideas like this into the infrastructure to bolster the US's economy, as well as our actual infrastructure to build chips in a more I think he was saying robust and new and creative ways. So I thought overall it was just really interesting to hear an expert's opinion and break it down to get it to where I could understand exactly the goals, aspirations, and dreams of this act.
Yeah, absolutely. And Ming is a very positive, optimistic person. And so we kind of asked him, what does that outlook look like? This CHIPS Act represents funding for the next 5 years, right? And then after that, it's almost TBD, to be decided. And so with that, we kind of asked, what impact will this make on established industry, bigger companies, but then also startups and even academia? And then we kind of tied all of that into its effect on MSEs, like students, young professionals, people who are potentially looking at the semiconductor space. And so I thought all of that was very insightful, and he offered very valuable advice to MSEs, the next generation of MSEs, in terms of what characteristics should they embody, what should they be doing, right, to set themselves up for success in the semiconductor field. So those are all things to look forward to. And before we get into the episode, just a reminder, we would really appreciate it if you could leave a rating and review on your favorite podcast platform. It would mean the world to us. So let's get into it.
All right. Hello, everyone. For today's episode, I'm happy to introduce Dr. Ming Zhang, an expert electrical engineer with nearly 20 years of experience in the semiconductor industry. Since receiving his master's and PhD in electrical engineering from the University of Illinois at Urbana-Champaign and his bachelor's in physics at Peking University in China, he has worked as an engineer at Synopsys, Intel, and Samsung Foundry. Ming has also been involved in entrepreneurship through his founding of Z-Glue in 2014, which focused on chiplet-based design for creating custom chips. Ming is currently an advisor for multiple deep tech startups, ranging from biosensing wearables to AI chips to photonic design and semiconductor manufacturing equipment. Thank you so much for joining us today, Ming.
Thank you for inviting me.
Yeah. So we're changing things up a little bit in today's episode where we're focusing on current events or, relatively a current topic, which is the CHIPS and Science Act. CHIPS standing for Creating Helpful Incentives to Produce Semiconductors, which has significant MSE related implications. So Ming, can you briefly describe what the CHIPS Act entails for US made semiconductors?
I think one of the fascinating things about CHIPS Act is it's able to catch attention from so many people. Some of them actually understand the meaning of chips as in semiconductors. Some of them don't even understand what chips is. And I think that's really, I would say on a personal level, the most exciting aspect is all of a sudden chips are becoming interesting and inspiring again, right? At a personal level. Now, going to the specifics, if I read the vision statement from the government, right, the vision is really all about enhancing the United States' economic security, national security, and catalyze and accelerate future innovation. Economic security, the enhancement of that is a result of enhancing supply chain security by having domestic manufacturing. National security is a result of being able to manufacture advanced, secure stuff onshore. And future innovation is a result of funding and increased interest. I think all of that makes a lot of sense. A big part of that effort, as I understand it, is there's a substantial amount of funding being allocated for A, manufacturing, B, future R&D. And it's going to also catalyze additional investment from private sectors, as I understand it. So I guess in short, I would say that from a technical level, I believe CHIPS Act will really help the United States make better chips done faster and more securely. At a more of an intellectual or philosophical level, like I said earlier, it's going to make chips more interesting and inspiring again. That's a great thing.
So you said that it would make chips faster, more innovative. Can you talk about that a little bit more? I guess to give more context, the Act entered its first round of funding last month in February, meaning that $50 billion would start to filter down to these R&D and microelectronic companies. So how does this first round of funding impact what you just talked about?
My understanding is the first round is focused on manufacturing, right, which is part one of the two, right? The second being R&D. Manufacturing, semiconductor manufacturing is probably not historically one of the strongest things in the United States. Right? A lot of manufacturing has actually left the United States. So with this funding, what I think is going to happen is that it'll increase the interest of existing players to invest more in building out the manufacturing capabilities. It'll attract new players to come to the United States to establish manufacturing. At some point, I'm assuming sort of part two of the funding, meaning the R&D funding, will also be released. And I think that logical order actually makes a lot of sense, right? Once you have sort of the critical mass of manufacturing, making stuff, and then you catalyze the activity to create stuff on paper, i.e. R&D, right? So that logical sequence actually makes a lot of sense to me.
So just from like the context perspective, I would like you to kind of paint a picture of the current landscape. So I was wondering what percentage of chips are made abroad, overseas versus, domestic in the United States, and how do you envision that'll change over time as a result of this CHIPS Act?
Right. Well, currently there are multiple statistics floating around, and they typically categorize the statistics by mature process node, bleeding edge node, and advanced packaging, all that kind of stuff. For pretty much advanced node, most of it, if not all of it, is made outside of the United States. That's probably the most interesting stats, right? And even on the mature node and packaging, I would say overwhelmingly more than one half at least is made overseas. So if you look at the funding plan, I believe that was the notice of funding that was released 2 weeks ago. What was mentioned was a two-step process, I believe. The first step was trying to catalyze activities around bleeding edge node, and then mature node and backend processing. So that's actually going to have a broad coverage for everything that I just talked about in 2 steps. So it'll increase the proportion of manufacturing done onshore.
Okay. And then can you just explain a little bit what those differences are between like mature node, advanced node, and packaging?
Yeah. So you see that we semiconductor people try to be positive sometimes, right? So but mature node is really another way of saying older node that tends to be less high performance and less power efficient, right? So it's mature, right? Instead of being worse, right? That's first aspect of it. The leading edge node, as the name indicates, it's really the leading edge node that tends to generate or tends to be where the new stuff is being made, like most cutting edge iPhones, the MacBooks, and the chips in Tesla, that kind of thing tends to be in the leading edge, or of course the data centers. So there's usually a performance slash power benefit going from mature to leading edge node. Now, why would mature node even be relevant, you would ask, right? If everything newer is better. Well, most of the time, mature node is cheaper because it's mature, and a lot of the applications may not need the sort of the cutting edge speed, right? And in fact, some of the older process node have additional advantages in terms of, for example, being read hard, right, or being super low leakage, right? So that they will find applications in certain market segments. Backend, right? That's neither leading edge nor mature node. Backend is probably another name for chiplet or advanced packaging, right? Basically it's another way to enable heterogeneous integration of different chiplets coming from different process nodes. So the system architect will be able to build the best combination of best-in-class components without being confined or restricted to either leading edge or mature node. You can have the best of both worlds.
So when you talk about this funding of manufacturing in America and trying to bring up our capabilities, what type of lag will we have? Like we've invested money now, but manufacturing takes a while to build up. How long do you anticipate to reach that critical mass of manufacturing to release the second round, like you said before?
Well, I wish I know the answer. I wish I know the precise scientific answer. Actually, even if I do know the answer, I shouldn't be saying this here on a public forum.
Totally fair. Totally fair.
I would like to think, right? Let's think about the dynamics or the time constants of the industry, right? I think for manufacturing, somebody puts money into manufacturing for the factory to get to a steady state of being able to produce stuff, right? That we're looking at probably 2 to 3 years minimally, right? That's from an idea or prototype to some steady state production of chips, 2 to 3 years at least, right? So I would like to think probably a positive, very positive guy, aggressively positive guy. I would like to think that 2 to 3 years is a pretty good time constant to anticipate the manufacturing getting to a good state. Now, R&D, ideally, in a perfect world, right, you have a very good state of manufacturing. Then you go all of a sudden generate a bunch of R&D ideas. Then you go make them, right? Ideally, you do it sequentially, meaning you're going to start doing this in 2 to 3 years. But the problem is if we do that, we're going to be late, right? So I would like to think the right way to do it is to stagger it, right? To almost simultaneously start catalyzing the R&D investment in anticipation of the ramp up of manufacturing, let's say 2 to 3 years, just to make it work, right?
Yeah, for sure. So now I'm curious, for startups in this space, how does that potential timeline, right? How does that affect, next series of funding, right? Like, is it just, signs of progress, which will potentially lead to getting that next step in funding, that next series in funding before that 2 to 3 years is up? Or is it like kind of, once we're there 2 to 3 years from now, then we can evaluate, next funding options?
Well, predicting future is always a dangerous business. That could be a startup idea too, right? I would personally be inclined to take actions before the world all agrees, right? Meaning please don't wait until when everything is clear and then take actions. I would think the whole point of startup is being able to take risk and take actions quicker with more agility, with stronger focus compared to bigger companies. Part of that involves actually understanding what's going to happen, but a big part of it is probably guessing it or gambling a little bit based on ambition or conviction. I think the best time to act is going to be now instead of waiting for the right sign.
Yeah, Makes sense. And so now I would like to kind of compare, you talked about bigger companies versus startups, and you've had experience at, Synopsys, Intel, and Samsung Foundry, and then now you're kind of an advisor for deep tech startups. So what do you think will be the differences in terms of the actions that the CHIPS Act will prompt for bigger companies versus startups?
Where my big company industry had, I would probably want to start paying more attention to strategic directions as opposed to quarterly earnings and profits. Now, to be clear, quarterly earnings and profit is extremely important. Without it, there's no company. Personal level, I felt like in the past for a few quarters, there's a little bit of overreaction to quarterly profit and earnings. If I were wearing the big company hat, I would probably need to think more, invest more into what the strategic plan is, right? More than a few quarters, a few years. If I'm a startup and wearing a startup hat, I would probably like to think that this is a great opportunity for me to take on a really big problem and solve it, even if I have 0.1% of the resource of the bigger company. And the reason is that if I'm a startup, I'm able to innovate with a stronger focus, with a higher velocity, better than the bigger companies. Especially now, there's a guiding North Star, right? A guiding North Star being CHIPS Act, right? Just to be clear, one of the things I've been kind of carol discussions with friends, I'm like, don't refer to CHIPS Act as CHIPS money, right? A lot of people say CHIPS Act. It's like CHIPS money. Let's go get some CHIPS money. Well, I think money is part of it, but it's really all about CHIPS Act as a guiding North Star that sets the big direction, that gets people excited, and it gets people to be motivated toward one thing instead of a million things. So I think that North Star is really going to create a healthier environment for the startups that I believe would help them focus on what they do the best, which is innovate faster with focus.
So you're talking about how first it's the money, but also it gives guidance to kind of the US industry's identity for semiconductors. How effective do you think this will be over the course of the next 5 years, as CHIPS funding will then end after those 5 years?
I think the early signs are already here, right? You can see that several big companies are establishing factories as catalyzed by the funding. Even before the funding, some announcements are made. To my knowledge, also, there's a lot of research consortiums are really accelerating momentums on establishing research plans, aiming for the upcoming NSTC and other R&D activities. Of course, all of that are confidential. They're probably not talking too much about exactly what innovation is public, but people are getting excited, right? And it's a fascinating thing is, I would say last year, I probably visited more professors and universities than I have ever done in my entire life, right? It's fascinating. Well, other than when I was being a student, right? When I saw students, professors every day, right? It was interesting because I was working for a bigger company, and why would that be, right? Well, I think the reason is that all of a sudden the company was interested in strategic collaboration with professors, and the professors all of a sudden are feeling a stronger motivation to create newer, better ideas, and also lean forward to collaborate with industries. I think last year was fascinating, really just being able to observe that increased frequencies of interaction with professors. Now, that's sort of last year and now, right? I guess the other part of the question you're asking is what about in the future? If I understand correctly, the whole point of CHIPS Act, the funding plan, probably supposed to be covering 5 years, right? Now, what's going to happen after 5 years? I don't know if anybody prescribed a plan. I would assume the right thing to do is to continue to catalyze and attract private sector funding, right? A little bit less now, but definitely more later. So by 5 years or 6 years, it'll get to a steady state that the catalyst is depleted, but the society, the industry now, all very excited to continue to drive them forward, right? With a lot of private sector involvement. And I think in my opinion, that's probably where the real excitement starts, right? If it's a very good thing the government is willing to give resource and give money and providing guiding North Star for the industry. It's a very good thing. But it's probably not sustainable if nobody else wants to do it, right? So it's very important for everybody else to want to do it, industry, academia, and VCs, right? So I'm looking forward to that a few years out.
Now
Yeah.
I'm curious. So let's fast forward 5 years. What does success look like? Like, what would from the results perspective, because I know you've talked about the excitement, right? So how does that drive results 5 years from now? Is that potentially, more semiconductor manufacturing facilities, more companies operating in this space within the US? What exactly do you think that looks like?
5 years out, I think there's certain things that's clearly written on the plan, or certain things that's going to be my prediction or perception, right? And what's going to clearly happen is going to be the larger percentage of manufacturing being done onshore, right? And also a higher percentage of R&D that experiences transition from lab to fab, right? Those are the two key components of CHIPS Act that's pretty clearly described in the CHIPS Act. What else? So the fascinating thing about getting interviewed by your podcast was I never anticipated it because this never happened to me before. I mean, it's interesting because I think we've come to a point, at least from my point of view, I don't know if we would want it. Generally, the community is willing to talk as much about material science, circuits, chips, semiconductors. So when I got the invitation, I'm super excited. So one of the things I think it'll happen in 5 years, right? What happened today will be multiplied by 1,000 times more, right? I think there's the economic productivity, right? There's the national security, there's the number of papers being published, all of that, all of those count. But the one thing that's very hard to measure and very subjective is the level of interest and level of enthusiasm, right? I really think that 2 years out, perhaps there's going to be 1,000 times more of such podcasts, maybe at least such conversations, talking about material science and circuit designs and semiconductor chips is no longer a privilege. A bunch of PhDs, no pun intended, right? Perhaps, right? More people, more companies would be willing and able to make custom chips faster, right? Either with monolithic technologies or with 3D technologies. I think that's the future that I'm really looking forward to, is where a lot more organizations and individuals can actually make tangible impact to chip innovation by either writing a paper or by making a chip or just by talking about it more. Right? You don't have to be a PhD to do that.
Absolutely. And so you mentioned PhDs, right? So what do you think sparked this, increase in communication back and forth with professors and industry, or, between academia and industry, specifically within the semiconductor industry?
I think one interesting aspect of it is with the increased communications, I have seen some interesting things happen, meaning there are so many things I thought I understood, right? Having done my own PhDs, having worked in circuits and chips for so many years, and having formed an opinion, a lot of that was wrong, right? It's just really, I think part of the challenge, at least I was observing, is in the past maybe 5 to 10 years, collaboration between academia and industry in meaningful ways on advanced circuit design, advanced materials, advanced chip design has really degraded substantially. What I found was a lot of what I think I know was wrong, right? I'm glad I know that now, because this is really by being able to have more conversations, more high quality conversations and collaborations between industry and academia, we would be able to open the aperture of innovation. We would be able to increase the velocity of turning idea into tangible product. And with the right structure, I believe one of the things that CHIPS Act would do is to put in the right structure or governance in terms of NSTC, et cetera, that will do it in a very structured and fair manner. I think we're going to see many new ideas. And more importantly, we're going to see a substantial proportion of that new ideas becoming useful products in the field.
So for the energy sector, for batteries, for example, the Department of Energy has been a really big driver and funder of clean energy. I guess my first question for you would, do you think that the CHIPS Act could kind of serve the same purpose for the short time? And then also, recent legislation has also made that any funding that you receive from the government for academic research, you have to publish all your data, which has been previously not accessible. How do you think the greater access to the fundamental data of the studies that they're contributing to in the science field could affect the semiconductor-based research industry in academia even more?
So I was telling Beneath earlier, I was actually very close to where he is on Friday, attending a workshop run by NSF in the area of AI-driven EDA. One of the challenges that everybody talked about was lack of access to data, right? Lack of access to data in the form of test cases, right? Training cases for AI algorithms, lack of access to benchmark results. Basically, in other words, it's very hard to build algorithms without access to data. It's also very hard to compare algorithms if you don't have a way to benchmark them. So it's not very good, right? So, but those are the commonly recognized challenges. The reason why I mention this is I think the community, the industry / academia community has realized the importance of access to data, whether it's on the receiving end of input data, right? Meaning models for materials, models of circuits, PDKs, and test circuits, or on the output side, meaning the result in a more understandable way and benchmarkable way. I think it'll probably provoke, I would say, healthier benchmarking. More importantly, it'll be able to accelerate the innovation, a transition of innovation from an idea into a product. Because without the benchmark, without transparency, it's going to be really hard, I think, for any company to look at a paper and say, do I believe it or not?
So then kind of switching gears a little bit, we've talked about industry and startups and the potential impact of the CHIPS Act on those areas. How do you imagine that semiconductor-based research and academia will be affected by the CHIPS Act? Will it be a similar impact, or will it have a different influence because it's more research-based and more academic focus?
I think academia is playing, I think, a two-folded role, right? Or on the one hand, major disruptive discoveries, right? Big changes, almost guaranteed will probably come from academia, right? Because most of the industry folks are really more focused on producing a steady stream of product releases and revenue, which is all very important, right? But that makes us distracted from looking over the horizon, looking beyond the unknowns. So academia needs to discover or make the really big disruptive discoveries. Now, the challenge is, will academia be motivated enough to continue doing this, right? Meaning, A, are they going to get enough funding? B, are they going to get enough students? And C, if they generate all these papers, would it go anywhere in terms of becoming part of a product? The A, B, and C's, right? I would like to think that the academia, the research community would really benefit from what's happening right now because A, there's going to be a localized infrastructure to manufacture stuff, which to me means a faster transition from a concept to a physical thing. And B, there's also a workforce development component to the CHIPS Act, which would produce probably a more richer stream of talents, not only just workers in a factory, but also I think students who have interest in the field. And then finally, in terms of motivation, when all the companies, whether they are foundries or chip makers or system makers or software companies or equipment companies, if they're all talking about innovation, I think that's sending the right signal to the academia. Now, all of a sudden, this is all important. So I think academia has a lot to benefit from.
So you just said that one of the goals or one of the outcomes will be a richer stream of talent. And so as recent graduates, if we flash back 5 years, and so now we want to get into the semiconductor industry, what type of jobs do you think will be available within like the first 2-3 years with like the manufacturing focus, and then the next years after that with a more R&D focus?
I think the short term, I would like to say that as triggered by the funding with the two focus areas of manufacturing and R&D, I think both would probably experiencing a spike, right? Manufacturing-centric jobs and research and development jobs, because it's directly tied to the increased activity, whether it's a factory or a research or product development team. Short term, I think that's quite predictable. Long term, I would like to think that innovation may or may not take a fixed form, right? And it may just be that after a few years, there's going to be a greater demand for US-based deep tech startups and entrepreneurs, right? So nobody knows what that is, right? Because the innovation hasn't happened yet, but it's generally maybe just a group of people that are willing to do that kind of stuff, right? I think maybe a few years out, there's going to be a greater demand for entrepreneurs.
So the CHIPS Act has gone under a lot of legislation and a lot of compromises. I guess looking forward to maybe the next round, let's say, like you said, there might be like a smaller round of funding or something like that. What in the CHIPS Act that was struck out this time do you think may be revisited, or what areas of the bill that hasn't been covered would be the area of focus in the future?
Focus of the future notice of fundings or
Yeah. So let's say the government wanted to do another round of funding to continue to catalyze the semiconductor industry after this first round, after 5 years, has run out. What do you think that might look like?
oh, I see. After the first 5 years have run
Yeah.
out. I would like to think that there has to be a plan to attract private sector funding, right? It cannot be, I don't think it'll work if it's yet another bucket of money after 5 years from the government, right? I mean, money is good, but then it's actually not very healthy, right? And it literally becomes free stuff. So I would like to think that there's probably the right plan could be, in my personal opinion, to have a staged plan, accelerate getting private sector funding so that maybe at fifth year, maybe at fourth year, sixth year, majority of the funding is really private sector money. I don't know as a fact. I would like to think that's probably more logical.
And then what does that like funding allocation look like? This is just, just the curiosity side of me. And how is it allocated? This $50 billion investment between startups, more established companies, academia, et cetera, or how will it be allocated, if you know?
I don't really have any insights other than what's published on chips.gov, right? Probably share what I think I know from the website and maybe share some personal perspectives. I think what's published there essentially says that 39 billion is going to manufacturing, including leading edge and mature node, and 11 goes to R&D. As to the next level of granularities, I'm not sure there has been any specific published numbers. Now, one thing that I'm personally very interested is to maybe figure out how much of this is, I think you also mentioned startups, right? How much of this is going to be useful to startups and through what vehicle, right? I don't really have the answer, but I'll be paying attention to it.
Yeah, for sure. Because we were just talking about it last week, honestly, of semiconductors and, bottom up additive manufacturing, the influence on the chip space. And our guest mentioned that one of the challenges is getting that investment from venture capitalists upfront, right? Because you have to kind of show the proof of concept, but it is that large upfront investment to be able to show that proof of concept. So do you think that would be kind of the Kickstarter, this initial funding, not from the private sector, would help kind of develop the technologies to show that proof of concept, and then there's something there that venture capitalists can see and be like, okay, this is worth the investment or this is not worth the investment?
Very good question, right? And this goes back to my deep root in startups. On the surface, the problem may appear to be, oh, it's so hard to get money from VCs because they're asking for physical POC that I don't have, a proof of concept. I think if you peel the onions, I think there are probably 3 layers to this problem. I think the first one is that it's generally harder to make a physical product as opposed to a piece of software code. Now, when you have local R&D and prototyping and manufacturing facilities, I would like to think that would help this particular aspect, right? If you have an idea, it'll help you convert an idea into a physical product. Now, you're going to still need to spend money on it, right? That's a different problem. The second problem is really on the VC, right? Meaning VCs are generally, as I understood it, they can be a little bit negative towards semiconductors, right? Because it's long investment cycle, long product development cycle, high risk, right? And I used to joke, right? I'll pitch to maybe 200 VCs to get 5 meetings, and one of the 5 actually give me money, right? So I think that it is what it is. It's just, it has anything to do with the VCs being bad. I think it is what it is. It's the market dynamics sending that signal to the VCs. What I'm hoping would happen that might change the VC's opinion is that with North Star, right, guiding the directions. Besides providing funding and catalyzing R&D, it's also making the industry a lot more interesting and inspiring, as I said earlier, right? Maybe the VCs will also be inspired. I think the third aspect is on the entrepreneur themselves. Now, let me kind of rewind a little bit. The first point I said was really generally just the general dynamics of physical product. It's harder to make that compared to a piece of code. That's just general dynamic. Number two is the perception of investors, which is very well justified. Number three, I think it's really has to do with entrepreneurs. But today, if you're going to build a company, you may want to think hard whether you can create a new market or create a new concept of a product. If everybody in the world believes that it takes the actual physical piece of chip that's produced at the HVM high volume fab, that's the only way to do the POC, can you change their opinion? Can anything else be done to make the point, right? Can it be a emulated result on a piece of emulation hardware? Can it be simulated on a software? Or can it just basically be a better story? I think there's room for improvement.
Definitely. And I know you're very excited about this space and seeing what'll become, and how will this investment influence, right, the growth of US made semiconductors and this domestic industry, this domestic sector. A large portion of our audience is MSE students or young professionals who may or may not be looking to get into the semiconductor industry or transition to the semiconductor industry. So I was just wondering, to wrap up this episode, do you have any advice for MSE students or professionals looking to score one of those new semiconductor jobs or just get involved in this growing domestic sector of the semiconductor space?
Yeah, products run on chips, and chips are made of circuits, and all circuits are fundamentally made of materials, right? So materials are going to be the driving force of every major innovation forward. I think that's the right field. Now, it's a very hard field, but that's why it could be very rewarding. Right. And incidentally, 2 weeks ago, I was listening to a public seminar run by the Industrial Advisory Committee. They talked for CHIPS Act, right? They talked about sort of the future vision of CHIPS Act. They talked about the organizational structure of the CHIPS Act. And one thing in particular they talked about is they're going to hire a CEO for the NSTC, National Semiconductor Technology Center. One line in their talk really caught my eyes that might be interesting to the students. What they said was they want the CEO profile to be global, bold, and creative. So the CEO is going to run an NSTC, which is going to play a very important role of the future semiconductor research for the United States. And the committee wants that person to be global and bold and be creative. And so that's what I think the students should be. Right? Every one of the students should be aiming for that, to be potentially becoming the CEO. And it's important because these attributes are important, right? Be global, meaning that as much as your focus area might be a particular material subject matter, look over the horizon, look beyond your expertise, right? Look at the bigger picture of what product are being built and why is it that product needs this material. Be bold, obviously, take risks. Actually, it's much easier to take risks when you're younger and having more energy, right? And be creative. Innovation sometimes takes the obvious form of technological innovation, right? Here's a new material made of new atoms. That's one form. Another form is to permutate the technology that already existed to make a new product. Another way is to sell the product in a different business model or to a different market. So be creative about technology and product and market creations. To summarize, maybe get more inspired by the job description of NSTC CEO and be bold, be global, and be creative.
Awesome. I really love that advice. Thank you so much, Ming, for joining us today and sharing your insights and sharing more information about the CHIPS and Science Act. It was very insightful, and I really appreciate your time.
Thank you.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.